if you were adding up an infinite number of terms, that would just become infinitely large, right? And, you know, for this first series, which is arithmetic, right, if I keep adding another number, every time I add another number, the sum changes, which means it doesn't really have a sum, because every time you add another number, it changes. So, you know, is it possible to evaluate an infinite arithmetic series? No, it's not. Impossible. The second one is a geometric, right? Because it's times 2, everything is times 2. But because these terms keep getting bigger, right? Every next term that you add is going to change the sum. Right? There's no way you'd be able to evaluate and say, I add up an infinite series, I'm going to get one fixed number. Not possible. Okay, but the last one, that's also geometric, right? What does it look like the R is in this case? A half. You're multiplying by half to get each next term, right? The terms appear to be getting smaller. Well, notice this. What if I say that this board from this side to this side is 1 unit long, okay? And I'm going to go from one side to the other by taking steps where I go halfway to the end with every step. So if it's 1 from here to there, my first step will take me halfway, right? So that's 1/2. And my next step will be halfway to the end from here. How much of a step is that going to be? 1/4, right? How much so now I'm sitting here at 3/4. How much is 1/2 of the way to the end? 1/8. Okay. So you see what's going on with these numbers. That's clearly a geometric sequence, and the R is 1/2. But if I keep going to the end by going halfway there, am I ever going to get to the end? No, I'm going to get infinitely close, like a graph of a function does to an asymptote, but I'm never going to touch that. When that happens, you say that it converges to that number, right? We're going to say that it converges to 1. Even though it's like so infinitely close, it's actually not quite there, but it's infinitely close. So under certain circumstances, you can add an infinite geometric series and it'll converge to a sum. And the condition is the terms got to be getting smaller. If the terms are getting smaller, it will converge to a sum. Now, what is it that makes the terms get smaller? We're multiplying times R. What does that tell you about the value of R if the terms are getting smaller? It's a fraction less than 1, right? It must be. And it turns out it can be a fraction less than 1, positive or negative. So anywhere between -1 and 1. So these could be flipping their sign. It would also work. And so when you have that condition, then this actually possible. That's the only time you can add up an infinite series, if it's an infinite geometric and the terms are getting smaller.